Hello everyone, so I'm going to start to go over 9.7, which is continuing our unit on volume. And this last time we talked about prisms and cylinders, now we're going to talk about pyramids and cones. So we're just going to start off with this formula for pyramids. And one thing that is different about this formula is that it has that 1/3 in the front, which we haven't seen yet. Another thing that's different is that although in the surface area unit we use the slant height in the formula, in this one we're just utilizing the regular height, which is the one that goes through the center of the pyramid. So let's try this formula out on number 1. We can actually start by finding capital B, which is our area of the base. Because our base is a rectangle, a 10 by 11 rectangle, I just want to start by finding the area of that shape first. So to find the area of a rectangle, you just do length times width, so 10 times 11, which would be 110. Then I would plug that in to the formula for volume. So 1/3 times 110 times the height of the pyramid, which is this length, the 16. And then we could just type all of this into our calculator and find out what the answer is. This comes out to 586.67 inches cubed. And remember that when we do volume, our units should have that little 3, and we read that as cubed. And that's just a small difference from when we were talking about area and surface area. Those units are squared. Okay, number 2, we would take the similar process because our base is also a rectangle. So let's start by finding the area of that rectangle. 21 times 9 would be 189. And then we can use the formula for volume. So 1/3 times our area of the base times the height of the pyramid, which is 5. So we plug all that in and then type it into the calculator. We end up with 315 yards cubed. Next is number 3. This one we can see that the base is a square because both of those sides are 14. So to find the area of the base, we would just do 14 squared. And that would give us 196. So we would next plug that into the formula for volume. So 1/3 times 196 times our height. The issue is that this 25 is not the regular height that we've talked about going through the center. Instead, it would be considered the slant height because it's on the side of the pyramid and it has a little slant to it, which means that that's not the one that we want to use. We want to draw in some sort of line that goes from the tip all the way to the center. And because it's not given to us, we need to go about finding it using something that we know. If we draw in a line right there, and if you think about it, that would be half of this line because it's just going to the center from the edge. So that's 7. And basically what I'm drawing is a triangle, a right triangle. This side is 7, this side is 25, and I want to know what this is. So to find that missing side of the right triangle, we can just use Pythagorean theorem. I'm just going to go ahead and say x squared plus 7 squared equals 25 squared. And then we would simplify this. So there's a couple ways of solving this. There's the way that you can just simplify each one. So 7 squared is 49, 25 squared is 625. And then we would subtract this 49, subtract this 49. So x squared is equal to, and then 625 minus 49 is 576. And then we take the square root of that. So the square root of 576 is 24, which means that the height of this pyramid is 24, and that's what we want to plug into the formula for volume. Then we type all of this into the calculator, and we end up with 1,568 feet cubed. So this is our answer. Number 4, one thing that's different about this one is that our base is a triangle now. So when we find the area of the base, we have to use the formula for area of a triangle. It would be 1/2 times base times height. This is the base of that triangle, so 12. And then the height of the triangle has to be this line that's perpendicular to the base, so the 7.5. The height of the triangle is different from the height of the pyramid. One is on a 2D shape and one is on a 3D shape. So let's find this area of the base. It would be 45. And now we can use that to find the volume. 1/3 times 45 times height of the pyramid is last, so that would be this line, the 10. So 1/3 times 45 times 10 would give us 150 millimeters cubed. Okay, now let's look at number 5. We have another triangular pyramid here. This is our base. And we would start by finding the area of that triangle. So 1/2 times base times height. Notice how this is a right triangle. So this could be the base and this would be the height of the triangle because that side is creating a right angle. So 14, the thing is we don't know what this side is, so we have to use Pythagorean theorem again to find that. It's like if I went off to the side and said 14 squared plus x squared is equal to, this 22.1 is across from the right angle, so that's the hypotenuse, which means that's the number that goes by itself. There's a little bit of a shortcut method if you don't want to go through all these steps all the time when you're solving for x on Pythagorean theorem. One way that I've showed sometimes is just going ahead and saying x is equal to, and then taking the square root of, because that's going to cancel out the squares, which is what we did in this step. And then this number just comes from subtracting this and this, and this. So what I'm going to do is write that here, but before I evaluate it. So 22.1 squared minus 14 squared, and then you can just type all of that in the calculator, and that gives you your x. So it's kind of a shortcut because then all you have to type is square root of 22.1 squared minus 14 squared. You can always think of this minus this if you're finding the hypotenuse, and it's kind of easier because you would just square root everything on the left side. So this would give us 17.1 as our x. So that's the height of the base, 17.1. And now we can find the area of the base. It would be 119.7. So to find the volume, we would do 1/3 times 119.7 times the height of the pyramid, which is this line, the 19. So the volume is 758.1 meters cubed. All right, so let's look at number 6. Once again, we are looking at a triangular pyramid, and the base, that triangle, seems like it's a equilateral triangle because all of the sides measure 10. So any one of the sides could be your base. The height of the triangle would just have to be some sort of line that creates a right angle with the base. So if I say that 1/2 times 10 times whatever the height is, and I don't know exactly what the height is, but I can find it by setting up another Pythagorean theorem. So if I know that this is 5, I can say 5 squared plus x squared equals 10 squared, because that's what the hypotenuse is. And then another way of doing this, just the simple way, going like that, simplifying, and then moving things over. So x squared is equal to 75, and then we square root that. So the square root of 75 is 8.66. So that's what we're going to plug in over here. and then that gives us our area of the base. That comes out to 43.3, and now we can say 1/3 times 43.3 times the height of the pyramid, which is this line, the 16. So this would give us our volume, 230.93 centimeters cubed. So those are some examples of finding volumes of pyramids. Basically, you're just plugging stuff into the formula and then using the calculator. Sometimes, if you're missing a measurement, you might need to use Pythagorean theorem in order to find out what that missing measurement is. So let's go to the next page and talk about cones. Remember, cones are just examples of pyramids, but they always have a circular base. So their formula takes that into account because we still have the 1/3, but instead of area of the base here, we just have pi r squared, which is the formula for area of a circle. So that's kind of like finding this area. And then we're still going to multiply that times the regular height, the line that's going straight through from the tip to the center of the base. So let's try this formula out on number 7. It's 1/3 times pi r squared. Our radius is 9, so 9 squared, and then times the height, which is 17. So this we can plug into the calculator. It would be 1,441.99 yards cubed. And that would be the volume. A problem like number 8 is pretty similar, except that instead of the radius, they're giving us the diameter. So we just need to take that number in half. That would be 2.5, and that would give us the radius. So now we can say volume is equal to 1/3 times pi times 2.5 squared times the height of the cone, which is 8. So we would type all of that into the calculator. That gives us 52.36 inches cubed. Number 9, there's a couple things we have to do. First, we still don't know the radius, so let's take this divided by 2. That would be 13.5. And this 22.5 is actually the slant height. And I want to know what the regular height is in order to plug that into the formula for volume. So I need to find out what this is, which means that I'm going to go off to the side again and write out a Pythagorean theorem equation. We can say x squared plus 13.5 squared is equal to 22.5 squared. And then we can solve this using the shortcut method. So square root of 22.5 squared minus 13.5 squared. And x is equal to whatever the square root of 22.5 squared minus 13.5 squared is, which would be 18. So the height of the cone is 18. So let's say 1/3 times pi times 13.5 squared times 18. And you could type all that in one line, and it would give you your volume, which is 3,435.33 kilometers cubed. So this is our answer. Number 10 says a cone has a volume of 1,309 centimeters cubed. If the height of the cone is 8 centimeters, find its radius. So this problem is kind of like those that we've seen a couple times before, where they give you the answer, whether it's volume or surface area or area, and then you're supposed to find one of the measurements, which means that we just kind of have to think of it backwards by plugging everything that we know into the formula. We're going to be using the formula for volume of a cone again. This is our volume, so 1,309 equals 1/3 times pi. I don't know the radius, so I'm just going to leave that as r squared. And then I do know that the height is 8, so I'm going to put that in parentheses. And what I would want to do now is solve this as if it was an algebra equation for r. So what I can do is simplify everything around the r. So take 1/3 times pi times 8. And that would give you that number that we can put next to the r squared. So 1309 is equal to 8.38, And then we need to remember to bring down the r squared. So the 8.38 and the r squared are being multiplied because they're right next to each other. So to undo that, we would have to divide by 8.38 on both sides. So r squared is equal to 156.25, and then to solve for r, we would just take the square root of that. So r is equal to the square root of 156.25, which is 12.5, and then this is centimeters. Remember, we don't need the cubed part at this point because we're not measuring volume, we're just measuring the radius. So number 11 says that Caitlin must build a sandcastle in the form of a square pyramid for a project as shown to the left. She bought 3 bags of sand, each containing 1,200 inches cubed of sand. Will she have enough sand to build the castle? So she wants to build a sandcastle and have it be a solid, so filled up with sand, basically. And anytime that you're thinking of building something or filling it up, you want to think about the volume. So let's start by finding the volume of this pyramid on the left. And it looks like it's a square pyramid because the base here is a 25 by 25 square. So we can start by finding the area of the base. Remember, this formula is 1/3 times area of the base times height. So to find the area of the square, we could just do 25 squared, it's 625. And then to find the volume, we would do 1/3 times 625 times the height of the pyramid, which is this line, 18. So when we multiply all those things together, we get 3,750 inches cubed. So that's how much it would take in order to build that pyramid in sand. She bought 3 bags of sand, each one having 1,200 inches cubed. So let's figure out how much sand she has total by taking 3 times 1,200. That gives you 3,600 inches cubed. And the question is, will she have enough sand? Well, this is how much she has, and this is how much she needs. It seems like she doesn't have enough. So we would say no, she will be 150 inches cubed short. She needs a little bit more sand in order to build the pyramid exactly as at those dimensions. Let's talk about 11. It says that the cylinder to the left contains 2 congruent hollow cones. If the cylinder's height is 20 inches and its diameter is 14 inches, find the volume of the solid. Okay, so what I'm going to do first is just mark up that diagram because I noticed that there's no dimensions on it. It says that the diameter is 14 and that the height is 20. So from here all the way to here is 20. And basically there's 2 cones inside of that cylinder and they're hollow. And we want the volume of the solid. So we can think of this as like finding the area of the volume of the cylinder and then finding also the volume of the cones. There's 2 of them, but they're each equal to each other. So we really just have to find the volume of one of them and then double that. And then we can do something with those. So let's start with the volume of the cylinder. This is a formula that we talked about in the last lesson. The volume of a cylinder was pi r squared times height. So let's apply that here. Well, the radius would be half of 14. So just up to here would be 7. So pi 7 squared. And then the height is 20. And that gives us 3,078.76 inches cubed. Now let's find the volume of the cones. There's 2 of them, so why don't we just multiply everything by 2 and put that formula for the volume in parentheses. So 1/3 times pi r squared, our radius is 7, and then the height of the cone would just be half of 20. So that would be 10, and then we can close that. So this would give us 1,026.25. And what we're going to do now to find the volume of just that solid part is subtract the two hollow cones from the volume of the entire cylinder. So we would take our 3078.76 minus this that we just found, the 1026.25. That gives us 2052.51 inches cubed. So that's the volume of the solid part that's left after hollowing out those two cones. So that's it for 9.7. Make sure that you complete the homework and the exit ticket, and we'll continue on in the next lesson.